Hello student, here chapter 1 I'll show you matter in our surroundings. Now you know what is matter that I am discussing. Matter, what is matter first? Matter, anything that has a mass, you see, anything that has mass, yeah, and occupies space, occupies 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 space, yeah, is called matter. Yeah, so this is the definition of matter. Anything that has mass and occupies space is called matter. So we'll discuss something on matter now. Matter, you have understood, anything surrounding you, everything is matter, like table, chair, yeah, pen, pencil, even you yourself is also matter. Because matter definition, they say anything that has mass, all the things has mass, that is the material contained in a body is called is mass. Yeah, maybe 1 gram, 2 gram, 3 gram, 4 kg, 5 kg, 100 kg. And occupies space in the sense anything which will have space, that one will assume volume. Clear? So that's why we can say that depending on that two term, mass and volume, we consider the things are matter. Now, here, in order to know about the matter, you have to know some terms here. Physical nature of matter. Now, they say it here, matter is made up of particles. Now, what are these particles? When we say one drop of water, if you take one drop of water, in one drop of water contains 10 to the power 21 particles. Just imagine. So, when we say 10, that means after 1 that is 10 to the power 1. Yeah. When we say 10 to the power 2, it is 100. After 1, 20. But when we say 10 to the power 3, we say 1000. So just you see, after 1, we are writing 30. So 10 to the power 3. So when you write 10 to the power 21, how big number is this? Just imagine. Clear? So we can say that in one drop of water contains this much of particles. Clear? 110 to the power 21 particles are there. So that you can understand doing this activity. Clear? So if possible, you try to do this activity, you'll be able to understand. Take a 100 ml beaker. You take 100 ml beaker, like this type of beaker. Then fill half the beaker with water and mark the level of water. Then dissolve some salt or sugar with the help of a glass rod. You see, glass rod. Then observe any change in water level. What do you think has happened to the salt? Where does it disappear? Does the level of water change? Now here in this activity, when you take the beaker and dissolve salt, the salt will get mixes with this water. That means you will not be able to see the salt. Now again you dissolve one more spoon of sugar, add with this water, again that gets mixed up with the water. So it seems that water has lots of lots of particles. Clear? So particles of water magnified millions of times, so that that gets dissolved, but the level of water is not rising. So we can say that when we dissolve salt in water, the particles of salt, actually that particles of salt get into the space between the particles of water. So between the particles of water, those shall get space and gets mixed it up. Clear? So that's why we are not able to see the salt anymore when we start with some glass rod and all. Clear? So this is this activity will through this activity we will help you to understand that matter is made up of particles. So just these are so small particles which you cannot see through a naked eye. Even through a magnifying glass also you will not be able to see the particles of the matter. Clear? So this is so small. So how small are these particles of matter? So that one also we can understand through this activity 1.2. So all this activity you have to go through it at home by yourself, then we'll understand it better. So I'm not going through this activity. So here another activity you see, in this activity they have shown 100 ml of beaker, 100 ml of beaker. Take out 10 ml of this solution and put it into the 190 ml of clear water. That means take out means potassium permanganate solution. This one here they say take 2 to 3 crystals of potassium permanganate. It's a one type of compound, and dissolve them in 100 ml of water. Yeah, if you dissolve that solute in this 100 ml of water, then what observations you can see? You see here, take out approximately 10 ml of solution. From there you take out 10 ml of solution, clear, then and put it into the 90 ml of clear water, and then put it into the 90 ml clear water. So take out 10 ml of this solution and put it into the another 90 ml of clear solution, keeping diluting the solution like this 5 to 10 times. And they say, is the water still colored? Yes, obviously the experiment shows that just a few crystal of water, potassium permanganate can color a change, color a large volume of water, about 1000 ml. So from here what we have understood, that means there must be millions of tiny particles, clear, are dissolved in it in just one crystal of potassium permanganate. So first of all we have dissolved in 100 ml, just few 2 to 3 drops, and from 1 ml solution we took it out and dissolved it in 90 ml of solution, solvent. Then these are the observations we can see, clear. So from here we can conclude that there must be millions of tiny particles present in it, clear. So just in one pinch of potassium permanganate can show you this type of color. Here the color of the solution is becoming little bit light, clear, when you are just dissolving with 10 ml. So here actually 100 ml, here also 100 ml. From here 10 ml you took it out, and in 90 ml by dissolving we are getting this observation. We are getting these observations. Again 10 ml you take it out from here, again you dissolve in clear solution, again the color you see more or less it will become this. So the color is becoming just with little bit light in color. Again you take out 10 ml from here, again you dissolve in 90 ml of solution, solvent. In this you see the color will almost remain the same pink in color, clear. So that means the color is not changing. That solution can shows that that means it contains lots of millions of tiny particles, clear. So this is about your that means we can say that matters are made up of tiny particles, clear. So those are very very small, so even beyond of our imaginations, clear, that we can say. Now here some characteristics of particles. So characteristics of particles, just we can say that particles of matter have space between them. So this one also you can understand doing one activity. So suppose if you take one here one unlight incense stick in a corner, clear. So suppose that one you not burned it, so from there no smell is coming out. Then after that you light it up, clear. Then what you can see, that means some smells will come out, clear, from that. So from a far distance even you can smell the incense sticks, clear, when if you just light it up. That means by sitting it from a far distance also you can get the smell of the incense stick, clear. It shows that the particles of matter are continuously moving, clear. So we can say that the particles of matter are continuously moving. So from here we have understood that particles of matter have a space between them. Particles of matter are continuously moving. So these things moves through a process that is called diffusion. I'll tell you the diffusion process later on in other chapters also. That means the rate of diffusion takes place in hot gases faster than the cold gases, clear. So that one we will discuss it in the next chapter also. So like this I have shown you this activity 1 and activity 1.1, activity 1.2. So this activity 1.4, 1.5, 1.6, 1.7 and 1.8 you go through it at home by yourself. Now from here you have understood the characteristics of particles are 1, 2 and another one particles of matter attract each other. So going through this activity also you'll be able to understand the particles of matter attract each other. So you go through that activity at home. So just I'll discuss little bit. Particles of matter attract each other in the sense, you have seen the shapes of any solid things, clear. So the particles of such matters are closely contact with each other, so that's why they assume some shape and they are solid in figure, clear. So those particles are closely contact, but they are actually contact. They say particles of matter that may attract each other, and if we heat the substance, anything just expand on heating, you know that. So just like rice or puff, if you heat it, you know that becomes big in size, so that expands in on heating. So from there we can understand the particles are just move from their original position just on heating, clear. So that's why we can say that particles of matter attract each other by just cooling the things, clear. So that way we can understand. Okay. Well, this activity you just try to study, and on this activity there are some questions. From there you have to guess which of the following are matter. Now you hear some words, terms are given. You see, chair, air, love, smell, hate, almonds, thought, cold, lemon, water, smell of perfume. So now you have understood what is matter. So from that idea, easily you can predict which substances are matter. Now just I'm saying that chair, air, then almonds, lemon, water, these and smell of perfume are matter. Clear? Why? Because all these things have mass and occupies space. But here the word you see love, smell, hate, then thought, then cold, these are not matter. Why? Even you can say the smell, the word, the sense of smell not mentioned, so the smell we cannot consider it as a matter, clear. Smell, if they ask sense of smell, that means that contains some volatile substance. Smell of perfume, we understand on that word, that means it has some uh, volume, that means it contains some volatile substance in the sense the substance which easily gets evaporated, clear. So and because of that you get the smell of perfume. That's why smell of perfume we can consider it as a matter, but not the smell, the word, clear. If we sense of smell, then we could consider, but it is not mentioned like that. That's why the smell simply we cannot consider it as a matter, clear. Now the again question number 2, give reasons for following observations, clear. That one we'll discuss with little. So the smell of hot sizzling food reaches you several meters away, but to get the smell from cold food you have to go too close. Now give reasons. Well, I've written it here, just I'm going through that, you'll be able to understand, clear. You see here, the smell of food reaches us by the process of diffusion of gases. Diffusion of gases means when the transference of gases takes place from one places to another, clear. So that takes place by that process, the diffusion process, clear. So I will discuss this diffusion in the next chapter more better way. So that is called diffusion process, clear. So the release by the food into the air, the rate of hot gases into the air is faster than that of the cold gases, so the smell of hot sizzling food reaches us quickly, even when we are several meters away. Clear? Because the rate of diffusion of hot gases released by the hot sizzling food is much faster than the rate of diffusion of cold gases released by the cold food. So what does it mean? Just I told you the rate of diffusion in hot gases takes place much faster than the rate of your in cold gases, and because of that if you want to get the smell from the hot sizzling food items, we from a little distance also we can get the smell of it. But if you want to get the smell of it in the cold food items, then we have to go near it and we get the smell of it. So because of this reason, so just you try to remember this one, and even you can write it as a note, and you can just from there you can write the reason from here. Okay. And in another questions they asked here, a diver is able to cut through water in a swimming pool. Which property of matter does this observation show? So this one also, I have written it here. You see, as you have seen, water is a liquid form of what? I mean, water is a liquid form of matter. Clear? Water is a liquid form of matter, that you know. The observation that a diver is able to cut through water in a swimming pool shows that though there is a quite strong force of attraction between the particles of a liquid like water which holds them together, but the force is not strong enough to hold the particles of the liquid in fixed position. You know, the force of attraction is strong enough in solid and little bit weaker in liquid and more weak in most weak in gases. The strong molecular force of attraction. Clear? So the particles which are closely stacked together in the matter. Clear? Physically we classify the matter physical, just physically, you know, physically, just let me tell you, physically we classify the matter into three types. What? Solids, liquids, and your gases. Clear? So this the particles of matter which are closely packed, that is in solids most, and little bit weaker in solid liquids, and most weaker in gases. Clear? That is the strong intermolecular force of attraction. So that's why we call it, that means which holds them together, but the force is not strong enough to hold the particles of the liquid in fixed position. So by applying somewhat greater force, clear, a diver is able to overcome the forces of attraction, clear, present among the particles of water, and hence cut through water in the swimming pool. Just remember, just to overcome this force, by applying a somewhat greater force, a diver is able to overcome the forces of attraction. The force which are present in the liquid, actually, that is strong enough just to overcome that force of attraction. He applies somewhat to remove the particles of water, clear, and hence cut through water in the swimming pool. Clear? So that way they can just do these things. Clear? Just remember this, by applying somewhat greater force, a diver is able to overcome the forces of attraction present among the particles of water. Clear? So these reasons you have to write only, basically. Clear? Basically, so here the long things I have written, just from here you can make it short and you can write it by your own. Clear? So remember, from your understanding only you are able to answer this. Now here, what are the characteristics of the particles of matter? Now that you have understood, the particles of matter are very, very small. So number one, we can say that the particles of matter, the particles of matter are very, very small, very, very small, that I told you already. And another point, the particles of matter, just you have seen here, have a space between them. The particles of matter have space, have space between them. Okay, this one you can write. And another one, number 3, you have seen here, the particles of matter are continuously particles of matter are continuously moving. So we can say particles of matter are continuously continuously moving. So this is one another point. And the last one, the you see particles of matter attract each other. Clear? So we can say particles of matter attract each other. So these are the things you have to remember. So on going through that, easily you can answer these questions. But I mean, again I'm reminding you, go through this activity, then we will understand the topic much better way. So for me it is not possible to go through all this activity. Clear? You go through it, all the activities. So remember that physically we can classify the matter into these three types, and chemically also I'm discussing. Chemically we classify the matter into an element, then compound and mixture. So these chapters also will read it later unit. Clear? So these things on matter I have discussed. So and in the next video I'll show you this part, states of matter. So remember only this much only. Clear? Leave it up to this much.